Hello everyone, my name is Elektra Belle from XIPAA from Sekolah Mondel Batam, and today we're going to learn about physics. Today we're going to learn the three laws of motion. So, the three laws of motion is found by Sir Isaac Newton. Newton's laws of motion are three laws that describe the relationship between the motion of an object and the forces acting on the object. So this motion is classified into three law of motion. Going back to the history, Sir Isaac Newton worked in many areas of mathematics and physics. He developed the theories of gravitation when he was only 23 years old. In 1686, he presented his three laws of motion in the Principia Mathematica Philosophiae Naturalis. By developing his three laws of motion, Newton revolutionized science. Newton's law, together with Kepler's law, explain why planets move in elliptical orbits rather than in circles. Now, let's go to the first law of motion, or it can also be called as the law of inertia. Inertia refers to the tendency of a body to remain at rest or to continue moving. It also says that the potential of a body to resist from any sudden change in motion. The first law of motion states that a body at rest will remain at rest, and a body in motion will continue moving at a constant speed in a straight path unless an outside force will act on it. Newton's first law states that every object will remain at rest or in ununiform motion in a straight line unless compelled to change its state stated by the action of an external force. This tendency to resist changes in a state of a motion is inertia. There is no net force acting on an object. Then the object will remain a constant velocity. If that velocity is zero, then the object remains at rest. If an external force acts on an object, the velocity will change because of the force. For example of this first law of motion is firstly a driver of the automobile brakes abruptly and by inertia shoots forward. So when a driver is driving a car and then suddenly an automobile brakes abruptly, then the person will go to the front. Secondly, a bicycle stored 5 years ago in a loft comes out of this inertia when a child decides to use it. As you can see from the graph here, sigma f becomes to 0. So it means that the total of the force is 0, and so the object doesn't move, or there is no acceleration. Now going to the second law of motion, or the law of acceleration. The second law of motion states that acceleration is directly proportional to the net force but inversely proportional to the mass. The acceleration of an object depends on the mass of the object and the amount of force applied on the object. So this equation, sigma f equals to mass times acceleration, sigma f cannot be 0. If it's 0, then it is the first law of motion. This equation tells us that an object subjected to an external force will accelerate and that the amount of the acceleration is proportional to the size of the force. The amount of acceleration is also inversely proportional to the mass of the object. From this equation, sigma f equals to mass times acceleration, we can say that acceleration is equal to sigma f divided by mass, or mass equals to sigma f divided by acceleration. The unit of f is Newton, or kilogram meter per second quadrat. Now, the example of the second law of motion is riding a bicycle. So bicycle is the object and it is the mass, and our leg muscles pushing on the pedals of our bicycle is the force. Because as we push our pedals, it accelerates, right? So you are increasing the speed of the bicycle by applying force to the pedals. Newton's second law also says that the greater the mass of the object being accelerated, the greater the amount of force needed to accelerate the object. Now, moving on to the third law of motion, or the law of interaction. It states that for every action, there is equal but opposite reaction. As you can see here, F reaction equals to negative F reaction. So whenever one object exerts force on another object, the second object exerts an equal and opposite on the first. His third law says that for every action or force in nature, there is an equal and opposite reaction. If object A exerts a force on object B also exerts an equal and opposite force on object A. In other words, forces result from interactions. We sometimes refer to this law loosely as action-reaction, where the force exerted in the action and the force experienced as a consequence is the reaction. We can say that N is the action and W is the reaction. Now, this is the force diagram or free body diagram. A diagram showing the forces acting on the object is called the force diagram. The object is represented by a box with forces that are drawn as arrows pointing away from the box, like as you can see here, sometimes called force diagrams. It is important to label each arrow to show the magnitude of the force it represents. Now, let's have some problem solving. So, number 1. A force of 50 newtons is used to drag a 10-kilogram box across the horizontal table. If a frictional force of 50 newtons is present on the box, calculate the unbalanced net or force on the box. Unbalanced net force is also equal to resultant. So, as we can say here, this is the force, it's 50 newtons, and this is the frictional force. The frictional force is always the opposite from the force. So the friction, as you can see from the question, is 50 newtons. And so if it goes right, it means it's positive. If it's left, then it is negative. So we can say that sigma F equals to 50 and minus 15 Newton. It equals to 35 Newton. And then calculate the acceleration to the object in problem 1. So as we can see, as we know from the second law of motion, the equation is sigma F equals to m times a, right? So we already count the sigma F and it is 35 newtons, and the mass is 10, so we find the acceleration. The acceleration is 3.5 meters per second quadrant. Now, the diagram below shows as a particle acted on by a set of forces. Given that the particle is at rest, find the value of P and Q. As we can see from the diagram, it states from the problem that the particle is at rest. So it means that the force given must all be equal from here and here, here and here. So we can say that 50 is equal to P, then 5Qn equals to 3 plus Q plus 10N. And so it becomes like this. We find the P first. As it is already obvious here, 50 equals to P. And then we just substitute the P to this equation. So we got Q 40. And so those are the answers. Now, given that the particle in this diagram is moving with constant velocity v, find the values of P and Q. This one is also the same, but we use elimination and substitution. So we can see here 3p minus 2q equals to 20n or 20, and then 2p plus q equals to 25. And so to make this q same, we times the first equation with 2. So 2p plus q equals to 25 times 2 becomes 4p plus 2q equals to 50. And then we cancel this by adding it, and then 4p plus 3p is 7p, then 50 plus 20 is 70. Then both sides divide by 7, we got p equals to 10. And then we substitute p into the first equation. So q equals to 25 minus 22p. And then we substitute the p, so 2 times 10 is 20, and 25 minus 20 is 5. Now, number 3. The diagram below is said to be accelerating at 2 meters per second quadrant. Find the magnitudes of the unknown forces x and y. Okay, so as we can see here, this is the diagram, and this is y acts for 2g Newton. 2g meaning 2 times gravitational force. So firstly, we find the x. Sigma fx equals to max. So x minus 4, like I said earlier, x is the positive one if the right one is the positive one, if the left one is the negative one. So x minus 4 equals to 2 times 2. As we can see here, the acceleration is 2, right, from the question, and we can just calculate already. So x minus 4 equals to 4. Then you move the 4 into the right side, equals to 4 plus 4, and x equals to 8 Newton. Then we calculate for the y. So how can the y become 2 times g, or 2 times gravitational force? You can see here, sigma fy equals to may, right? So y minus 2g. So if we're going up, it's positive, but if we're going down, it's negative. Y minus 2g equals to 2 times 0. Why it is 0? Because there is no, it doesn't move in the y-axis, it moves the x-axis. So y minus 2g equals to 0, and then you move the 2g to the right side, so it's y equals to 2g. And then you just substitute the g, or negative 9.8, and then 2 times negative 9.8 equals to negative 19.6. And so, if the question is decelerating, oh, I forgot to mention that if it is accelerating, then it goes to the right. It moves, it increases. So as we can see from the diagram here, y is this one, x 4g 80, and there is external force pushing the object. Okay, so we find the magnitude of the forces x and y, starting with the x-axis first. So sigma fx equals to max. So we can see here that the sigma fx is x minus 80, since both of these are the ones on the f-axis, equals to m, which is 4 kilograms, times negative 2. And then we just calculate it like the usual math, equals to 72 Newton. Now for the y-axis, or sigma fy, we can say that sigma fy equals to may. So there's an external force in here, so y minus 20 minus 4 times 9.8, because this is the weight, right, the w, so we times it by gravitational force. As you can also see here that 4g, so 4 times 9.8 equals to 4 times 0. It's 0 because there is no, it doesn't move up or down, but it moves to left or right. And then we just do the usual math again. So this one equals to negative 59.2, and so y equals to 59.2 newtons. So those are the answers. Now, moving on to force diagram on a system of a smooth pulley. Pulleys are used in different combination with other elements, but almost always with strings and blocks. So you can see here, this is a force diagram on a system of a smooth pulley. So the weight are different, right? So this is M1, M2, as you can see here, the weight are different, and the tension is the same. T1 equals to T2, we can say that tension of the cable is T. It is the same because it uses the same cable. So now you may be wondering, how can force act on a pulley? Force of friction will pull to the left of object one opposing motion. The force of gravity will pull directly down, and the normal force will pull in the opposite direction of the force of gravity, equal in magnitude. Tension will pull to the right in the direction of the pulley clockwise. Now, let's go to the problem solving. Question 1. Objects P and Q of masses 2m and 3m are attached to the ends of a light inextensible string. The string passes over a small smooth fixed pulley and the masses hang with a string taut. The system is released from A. Write down an equation of motion for P and for Q. B. Find the acceleration of each mass. C. Find the tension in the string. D. Find the distance moved by Q in the first 4 seconds, assuming that P does not reach the pulley. So here is the diagram, as you can see here. And for A, it says that to write down an equation for motion for P and for Q. For P, let's just focus on the object P here. So T minus 2 mg, because it's on the opposite. From the equation here, sigma F equals to ma, right? So for P, T minus 2 mg, T minus 2 mg, it is in the opposite direction, equals to 2 m, which is the mass, times A. And for Q, T minus 3 mg equals to negative 3 ma, because the mass is 3 m and the A is negative A. Now for B, it says to find the acceleration of each mass. So we just eliminate this by minusing it. So negative 2 minus 3, it becomes negative 2 plus 3, right? And equals to mg. Then 2 minus 3 ma, or 2 plus 3, equals to 5 ma. And so we cancel the m, and it leaves us to g equals to 5a. So a equals to g per 5 equals to 9.8 per 5, which approximately give us 2.0 meter per second quadrant. And then for C, it told us to find the tension in the string. So let's just pick one equation here. I'm going to pick for the P. Okay, so T minus 2 mg equals to 2 m, right? And then we just substitute the A here. We're going to use this so we can times 5 and cancel it, both the 5. So T minus 2 mg equals to 2m times g per 5, and we cancel the 5, so it leaves us to 5t minus 10 mg equals to 2 mg. T equals to 12 mg per 5 newton. And for D, find the distance moved by Q in the first 4 seconds, assuming that P does not reach the pulley. So this is D. This is D, not E. So we use the formula S, which is distance, equals to velocity times time plus 1/2 acceleration times quadrant. So the velocity is 0 times 4 from the question, plus 1/2 times 2.0 times 16. 4 times 4 is 16. And so we got 16 meter. So those are the answers. So moving on, other examples for force diagram. So given this is the force diagram, and it is asked to find the acceleration of the box for number A, and B, calculate the normal force between the box and the floor. So let's find A, the acceleration of the box. As we can see here, sigma fx equals to ma, and then 10 cos 30. Why is it cos? Because it is the f-axis, right? If it is the y-axis, then it uses sin. So 10 cos 30 equals to 8a, and we got approximately 1 meter per second quadrant. Now for the B, calculate the normal force between the box and the floor. So we find the normal force here. And so we use the equation sigma Fy equals to m times a. So n plus 10 sin 30, as I've said earlier, we use sin because it's in the y-axis, minus 8g because it is the opposite direction with the n, as well as the 10 sin 30, equals to 8, the mass, times 0. It's 0 because it doesn't move up or down, but it moves right or left. And so we got 33 newton. Number 2. A block of mass 10 kilograms slides down a smooth slope angled at 15 degrees to the horizontal as shown in the figure below. A. Calculate the magnitude of the normal reaction of the slope and the block. B. Find the acceleration of the block. So for A, as we can see here, it told us to find the magnitude of the normal reaction of the slope and the block. So it moves, we find the n, right? So n minus 10g cos 15 equals to 0. And then we just move this to the right side, so it becomes n equals to 10g cos 15, and we calculate it equals to 95 newton. And then B, find the acceleration of the block. We can use sigma fx equals to m times a. So the mass is 10 and the sigma f is 10g sin 15. And then we calculate it and we got a equals to 3 meter per second quadrant. Now moving on, given this diagram and we are told to find the acceleration, the tension in the table, the time of the system, and the acceleration of this one. So the acceleration between here and here is different. So now for A, the acceleration of the system, and for D, the acceleration only in this part, or each part of this. So firstly, we find the acceleration of the system. We use the equation sigma f equals to ma again, and we can see here t minus 0.06g equals to 0.60a. Now this is t going to the right side minus the friction here, 0.06g equals to mass times a. The mass is 0.60 times a. And so this is the equation for number 1. And then equation 2, here we can see that t minus 0.90g from the weight here, w. The equation is m times g, right? Mass times the gravitational force, so 0.90 times g equals to the mass, which is 0.90 times a. So this is the equation 2, and then we minus it to eliminate the tension here. And then we got 0.84g equals to 1.58, and then 0.84 times 9.8 divided by 1.50, we got 5.488. Then we round it off into two significant numbers, so we got 5.5 meter per second quadrant. Now for B, the tension in the cable. So this is one cable, right? So the tension between here and here is the same. We use the same equation again, which is sigma f equals to m times a. And so we can see here t minus 0.06g equals to, or we can just use the equation number 1. T minus 0.06g equals to 0.60 times a. And we already got the a, which is 5.5, so we just substitute the a here. And then we calculate it and we got 3.9 newtons. And then the time of the system. We use the the formula of s equals to velocity times time plus 1/2 times acceleration times the time being quadrant. So the s here, or distance, or the height, you can see this is 0.8. Then the velocity is 0, and the time, and which is question, plus half times 5.5, which is the acceleration that we already counted before, times t quadrant. Then we just do the math here, and we got 0.5 seconds. Now we find the acceleration in here. We just substitute it into the first equation, and we got negative 0.98 meter per second quadrant. So before we end this lesson, let's just close it with a quote. Here is a saying, "You never fail until you stop trying," from Albert Einstein. Keep that in mind. So that is all for the lesson today. I hope you understand what I was trying to explain earlier. Thank you for watching.